Alright, so today we're going to be doing the Ions lab, and the first part of that is a test for positive ions, which we will do using something called a flame test. So in order to do a flame test, you need a flame, so we're going to start the Bunsen burner, which we do by turning on the gas, and then we use our flint sparker, which does that, to spark our flame on. And if we turn the light off, we can see the blue flame shooting up out of the top there. Now what this is going to do is it's going to excite the metal ions in our salt into a electronically excited state, and they're then going to relax and emit visible light, which will be of a color different than the color of the flame. Another thing we're going to utilize is this filter. If we hold it in front of the flame, it filters out some of the brighter components of the flame and allows you to see more of the color detail, which will become obvious when we do the first flame test. So the way that we're going to do this, we're going to take a wet wooden splint and we're going to dip it into our salt. It will form crystals on the surface, and then we'll put the salt into the flame. So you see there, I have salt crystals on the end of the splint. And then if I take my filter and I place it up in front of the flame, my splint in. You can see also bright orange color. It's not so necessary for this one because of the big difference between orange and blue. There are a couple here that will make colors that are very similar to blue, and we'll need to have the filter to distinguish them. So that is sodium. And in fact, this property is made use of in something called a sodium lamp. Produces this bright orange color. You can see the splint is starting to burn now, and it's producing a slightly different orange. And I got a little bit of salt on the burner, which made a big orange flame. Take our used splint, put it in the water to extinguish it, and that is sodium chloride. The next part, we'll do calcium chloride. Now this one is going to be a much different color. Take our splint again. This one's warped from being set in the water, which I think is funny. And this healthy serving of calcium chloride on the tip of this. You can see here. To place it in the flame. I'll have the filter in hand in case we can't see the color. So see there, that is a red-orange. That's very different than the sodium color, and I'm sure that you can see how that is a redder colored flame. That is resulting from the different frequencies of spectral lines that are present in the atomic electronic structure of calcium. Once we have spent our salt, we again put the splint into the water. So far we haven't needed the filter yet to see the flame color, but for this last one, potassium chloride, we probably will. I'll show you both with and without. Splint. So it's healthy helping of potassium chloride. You can sort of see the different appearances of the salts. They have slightly different structures. And now, get ready to put this in the flame. So this one might be difficult to see, so look closely. See there, that's a light purple lilac colored flame. If we hold the filter up, you can see there's a difference in the color that's much more obvious with the presence of the filter. The filter's out the blue, you see only the purple-red color. So there you see there again, it's like a lilac when viewed in air, and it's a purplish magenta when viewed under the filter. Now that splint is burning, so we stick it in the water, extinguish it, and that is a flame test. So those are our 3 possible positive ions. And now that we've established our 3 standards, we will look at our unknown salt and determine which positive ion is present in it based on the color of the flame that is produced. And as you saw, all 3 of those salts have a distinct emission spectrum, and therefore it should be easy to tell which positive ion is present in this salt. So I'm taking my unknown, I'm taking the wet splint, placing it into the unknown to get a helping of it on my apparatus. Got plenty of it to make sure we have enough to do a really solid flame test. And now I place it in the flame. You see there is an orange flame. If you remember from before, that color orange was associated with one of those salts. I will let you determine which one for the report. Just use up as much of that as I can. You can see that. Alright, so now we are done with the flame test portion. To extinguish our Bunsen burner, you just turn off the gas and the flame goes away. So now we are in part B. Part B is the test for ammonium and iron 3 ions. So we have here our unknown solution of salt, which we are going to identify over the course of 2 additional tests. We're going to test first for ammonium and iron, and then we're going to test for sulfate and phosphate. But before we do that, I'm going to take this eyedropper and put some of my unknown solution into each of these test tubes labeled unknown. I'm going to make sure I get enough in there. Be careful not to cross-contaminate. This is a bit tedious, but it's done. Alright, so now we've put our unknown into 4 test tubes, and now we can put it away, for the time being anyway. Now the procedure says to also, for the first part, we're going to put out our ammonium chloride solution. So ammonium chloride is here. It is alkaline in nature. If you add its conjugate acid, it will turn into ammonia. So we're putting some ammonium chloride in here. And ammonium chloride, like I said, it stinks, so you can't notice it so much right now. However, in a minute, I'm going to demonstrate something that, like I'm going to demonstrate a smell. However, you won't be able to smell it, obviously, because you're at home, hopefully sitting on your couch. This is iron chloride. This is for the second part of part B. I'm just going to fill it up now for good measure. That one's a different color, you can see. Alright, so now we have our two test solutions prepared for the iron and ammonia test. Now, so for part 1 of part B, it says to take the ammonium chloride and add sodium hydroxide to it. Sodium hydroxide is a strong base, and it will steal the chloride from the ammonium and make it into ammonia and water. Sodium hydroxide is very caustic and can burn your skin, so you're supposed to be very careful with it. And apparently this bottle's almost empty. It says to do 15 drops. Six, 7, 8, 9. Okay, that was 9. Do a few more. 10, 11, 12, 13, 14, 15. And then it says to also add that sodium hydroxide to your unknown. So the unknown is here. Seven, 8, 9, 10, 11, 12, 13. Yeah, that's probably good enough. Now, one of the main tests to see that this is working is if you fan the vapor off of the top of that, you should smell ammonia. But the reaction requires heat to undergo. So now we're going to do a clever little test. We have red litmus paper. Red litmus paper turns blue in alkaline solutions, which have a pH greater than 7. When we talk about acids and bases, we'll talk about exactly what that means. However, the ammonia is basic, and since this reaction produces ammonia, if the litmus paper changes color, it means we have ammonia present. However, before we do that, we are going to place these test tubes into a warm water bath at 60 degrees. Okay, so now we are placing our ammonium chloride, which is seen here, a little ammonium chloride label. And put it in the warm water bath. And then we're going to take our unknown as well. We don't need to look at the label because it's just our unknown. We might actually put them away from each other just so that they don't interfere with one another. Now these will warm up, and you'll start to see a vapor forming on the inside of the test tubes. At this point, what we really want to do is we want to put litmus paper over the top, and that will either change color or not, depending on whether there is a base or whether or not ammonia is present. So we're going to give that a little time. Maybe even close this lid up for a second. Obviously, we don't want the litmus paper to fall off. And if we also may need to add a little water to the litmus paper in order to get it to actually respond. Actually, no, we don't. So look at here, we've already got a reaction. So you notice the litmus paper. Can you not see it? Okay, so here, I'll just pick it up. So for the first one, our ammonium chloride solution, you can see that the litmus paper has changed color. There's a little bit of blue in the middle where it was over the top of the test tube. So that means there, as we expected, there is ammonium chloride in the ammonium chloride solution. So that is the test. Now, however, you can also see our unknown solution has produced the blue litmus paper as well. So that is a positive test for the presence of ammonium in our unknown salt. And next we're going to test for the presence of iron. And we have to prepare some solutions for that. Alright, so for part 2 of section B, we're going to test for the presence of iron 3 or iron 3 plus. And it says first to put iron 3 chloride into one test tube and your unknown into another, which we have already done. And the next thing it says to do is to add 2 to 3 drops of 0.1 molar potassium thiocyanate, or KSCN, to each test tube. The presence of a deep red color indicates the presence of iron 3 plus, and a faint pink color is not indicative of iron. So if we take potassium thiocyanate and we dip it into our iron chloride, you see there it turned deep red like blood. Now, if we do the same thing, I used way too much of this, but you get the idea. Oh, weird. That one didn't react. I wonder why that is. So, hopefully you can deduce the conclusion that we come to from this particular experiment. Our iron standard turned blood red when we added potassium thiocyanate, but our unknown solution did not. So that is the test for iron, which concludes part B. Alright, so now we're going to test our unknown solution for the presence of a couple negative ions. So the first negative ion that we're going to test for is sulfate. We're going to do this using a sodium sulfate standard solution, and we're going to add that to one of the test tubes. The other one already contains our unknown from before. So there is our sodium sulfate, and there's the unknown. The next thing we're going to do is we're going to add a few drops of barium chloride. Now, barium chloride is here. It is the it's a salt in its solid form. But for this purposes, it's the barium is going to react with the sulfate and make a precipitate or a solid that falls out of solution. So I've got my barium chloride. First, we're going to check out what happens when we put it into the known sulfate solution. If you look down at the liquid, there is a white cloudy precipitate forming. Now, the procedure says to then add nitric acid, which is another highly caustic compound, just a few drops of it to make sure that we dissolve away any extra stuff. Anything that remains after we add a few drops of this will be barium sulfate. So shake it up a little bit. We still see all of that white cloudiness, which means that that has barium sulfate precipitate present in it. Now if we do the same thing with our unknown, oh, look at that. There is a cloudy precipitate that forms. And if we then go ahead and add some nitric acid for good measure, shake it up, the presence of a white cloudy precipitate is still noticeable. This leads us to conclude something about our salt, which I will let you conclude on the lab report. So we have done our test for sulfate, and now we're going to do our test for phosphate. So part 3 of section C in the lab manual, the test for phosphate ion, involves the addition of sodium phosphate standard to one of the test tubes, and we have our unknown already present. So I'll take a few milliliters of sodium phosphate, and it says then to take ammonium molybdate. It's a really complicated chemical formula. The purpose of it is for the phosphate to react with the molybdenum and form an insoluble precipitate. So we're going to take this and add it to each of the test tubes, and then we're going to balance it out with a little bit of acid just to complete the reaction. So the first, we go into our phosphate standard. And this one, she did that in the wrong order. I was supposed to add the ammonium. It shouldn't matter for this one since it's the standard, so I'm going to go ahead and now add the nitric acid. You see there, it's yellow. So now we have a color change. So that's the same color change that we're going to be looking for in our unknown. I'm going to do it in the correct order this time and add the nitric acid first. And I know that it's just about that much nitric acid. It's a very concentrated nitric acid solution, so you don't need a lot of it. And then I'm going to add our molybdate solution, which you've already seen. And if I drop it in, here you can actually see it sort of properly. As I drop the molybdate in, it forms brief precipitation, which is more like how it was supposed to look. However, notice that the color didn't change, which means that this is a negative test. So our unknown did not turn yellow when we added the molybdate and the nitric acid. The phosphate turned yellow, and so you can draw conclusions about that. That is the end of part C. We skipped a couple parts because we only need this to determine the identity of our unknown. So I will let you now determine the identity of the unknown salt based on the positive and negative tests you just observed. All right.